So we've been working with this new formula for exponential growth and decay. The formula looks like this. N equals N naught times 1 plus R to the T. N naught is the initial population in this case, because we're going to talk about a population problem. R is the rate, the growth rate, and T is the number of years. And then this N right here, that tells us our new population. So all the problems in number 26 are about demographics. These are all about populations. And in each case, they're asking us to find the population, the projected population in 2015. So in letter A, it's pretty straightforward. They give us the initial population of 836,231 in 1990, and we know the growth rate is 0.7%. We change that to a decimal, we pop it into our formula, and because we go from 1990 to 2015, that's, what is that? That's 25 years, and we put a 25 in to the formula, and we crank out the answer. It doesn't really get interesting until you get down to letter C and also letter D. In letter C and also in letter D, they don't tell us the rate. They just tell us what the population was in 1980. So we're going to have to use that information to figure out the rate first before we can use the formula to crank out the new population in 2015. And so here's how we're going to do that. What we're basically going to do is split this problem into two pieces. So the first piece is called get 1 plus r. And the reason I'm getting 1 plus r instead of just r is that in the course of my work, I'm going to end up with a 1 plus r equals, and I'm going to need a 1 plus r when I get to my formula over here. So I'm going to get 1 plus r and then just transfer it over to my formula so I can solve the problem. So here's how you get 1 plus r. You take a look at the information you're given, which in our case is we're given 1980, which is our initial value, and we're also given 1990, which in terms of 1990 is a newer value. And we'll plug those into the equation. We'll stick the 1990 where the n goes, so that's 139510, and that'll equal 139420 times 1 plus r, we don't know what that is, raised to the t power, but we do know what t is. From 1980 to 1990 is 10 years, so we'll put a 10 right there. And now our job is to solve for 1 plus r. And that basically takes two steps. The first step is to divide by 139420. That's our first inverse operation, 139. I got to write this a little bit better penmanship here, 420. We'll divide that out. So this one's gone. And on the other side, when we divide these, this is a very interesting number. It is 1.000006446. And that's going to equal 1 plus r to the 10th power. Now remember, we're trying to get the 1 plus r, but we don't want that 10th power there. So we're going to have to do the inverse operation for the 10th power. There's two ways to think of that. You can think of it as a 10th root, or you can think of it as raising this thing to the 1/10th power so that those exponents multiply to 1. So since I've already written 1/10th power there, I'll write 1/10th power here. And then you can crank this out on your calculator either using the 10th root or the 1/10th power, 1/10th exponent. And when you do that, you end up figuring out that 1 plus r equals 1.0000645. Not much of a change there, but it's significant enough that we're going to indicate it. So when we go over to the new formula, we're going to put this number right here into our 1 plus r over here. Okay, so let's go ahead and do that so we can finish this video off. I'm trying to find the projected population in 2015. I realize I'm recording this in 2021. The irony is not lost on me. It just means that this problem came from an old textbook. But based on these 1980 numbers, my new population should be projected to be 139,420, 139,420, that's our 1980 population, times my 1 plus R number, which is 1.0000645, and then I have to raise that to the exponent t, and that is the number of years from 1980 to 2015. My goodness, is that 35 years? It seems like just yesterday. Okay, so I raise that to the 35th power, and I crank this out on my calculator, and you can pause and do it on yours if you want, but I come up with approximately 139,740. And we'll go ahead and we'll make that an approximate answer there. Because I did have to round off to the nearest person, and because I also rounded off my 1 plus R here, even though I went to 7 digits. It's possible we missed a little bit there. But we've got 139,740 people projected to be the population of Janesville, Wisconsin in 2015. And so this guy is our answer right here. Okay. So I was worried that people might, not know how to attack this one because the R wasn't given. And the trick here is that you have to go and get your own R. And in our case, we're calling that get 1 plus R, right? And the reason we're getting 1 plus R is once you end up with 1 plus R here, you can just transfer it right over to the other equation. And you can see that we did use that right here, right? We used that 1 plus R number. Okay, so you should be able to use this process to do 26D. And that's a huge hint because, as I mentioned, I'm going to have you submit some answers at the beginning of class tomorrow. And 26D is one of the answers. So please take advantage of the fact that you spent 7 minutes watching this video. Go ahead and do 26D because I'm going to ask you for it tomorrow. That's your reward. You'll get some points just for giving me your answer on this one. All right, so use this process, see what you can come up with, and if you need me tomorrow, you know where to find me. In the meantime, take care.